and good evening, world. I'm Irene Pease, your friendly neighborhood astronomer. Welcome to your little Thursday evening stroll around your celestial neighborhood. I'm really excited for this week. I've started kind of a monthly series of what I call Mission of the Month. So each month doing just kind of focusing on either a current mission of space exploration or maybe a former mission of space exploration. It's hard to do future missions of space exploration because there's not a whole lot to say about stuff that's going to happen in the future. Not really stuff I can show from that. But tonight, November's mission of the month is OSIRIS Rex, which is a sample return mission to the asteroid Bennu. So excited to talk about that. But just to kick things off, again, I'm your friendly neighborhood astronomer. You can find out more at friendlyneighborhoodastronomer.com. I'll be showing some visuals from Stellarium. You can download that at stellarium.org. And also what you see in the background right now, what we'll be using a lot of is OpenSpace, which you can find and download for free at openspaceproject.com. So more on that in a little bit. But first I'm going to jump on over to Stellarium, which I like to use to do a lot of kind of night sky observing, planning. This is what I take with me out in the field, so to speak. And we're going to take a look at our skies this week. There was one thing I was really excited about, which is going to get clouded out, it looks like, but we'll improvise. So here we are looking at now. This is now live, if you're watching this live, as seen from Brooklyn, because that's where I am, facing west. So there's that tree. It's dark, so you can't tell, but there's this kind of big, obnoxious tree over here. And you can see the planets are sinking into the southwest, right? So it's getting darker earlier because we're on real time now instead of this daylight savings whatnot. Anyway, so Jupiter and Saturn over there, great, really beautiful targets. We'll see those over the next month, and I'll be gushing about those as they get closer and closer. We're just over a month away from the really amazing conjunction towards the end of December. Also, we have Mars. If we look high enough in the sky, Mars is up there, Uranus is up there, and Neptune is hiding somewhere. If you haven't had a chance to look for Uranus, I keep telling people look for Uranus this month because it's just past opposition, so it's slightly closer. Still kind of a challenge. But this next coming week, we have a new moon, so darker skies without any moon to kind of flood our evening sky, so a better chance of seeing that. What I was really excited about seeing was going to be out in the morning. So this is kind of like a moon thing in honor of upcoming Monday Moontopia. More on that later. But if you're used to getting up really early, there's this kind of neat thing that you would see tomorrow morning. And as everyone knows, tomorrow's Friday, 13th. But very exciting, kind of a beautiful show up. If you're up before 6 a.m., I would recommend like 5:30, between 5:30 and 6. So this is about, we'll put this up here so you can see, it's about 5:45, so 5:45 in the morning. Again, in Brooklyn, we're pretty far east in our time zone. But we have this nice little collection of planetary objects. I think on my website it says mostly planetary, mostly parallelogram. So you have Venus up there. If you can see Venus in a telescope, it's getting fuller. Venus is moving further away from us right now, kind of moving around to the other side of the sun. So it's getting dimmer and fuller. Ooh, look at that. You're not going to see the clouds in a telescope, but you might see the phase. You should be able to make out the phase in a telescope. And to the naked eye, it's just like this really bright spot. Also, Mercury. So Mercury is usually a challenge. Mercury doesn't get too far away from the sun in our sky. So it's always setting just after the sun or rising just before the sun. So it's often getting lost in the glow of the sun. But just a few days ago, it had its greatest western elongation, where it's as far away from the sun in our sky as it gets on one side. So this is a good time, a good week to try to catch Mercury. And because Friday morning, the moon's going to be in there, a little sliver of a crescent moon. So the moon, as you can see, is 27.6 days old tomorrow morning. So old for a moon. You should still be able to see a bit of it because there will be plenty of Earth shine. So remember, when the moon is a crescent, if you're on the moon looking at Earth, you see a nearly full Earth. So they have kind of opposite phases as viewed from each other at any given time. So there's plenty of Earth shine, this sunlight reflected off of Earth and hitting the moon. So it kind of lights up the moon so we can see it, even though only a tiny bit of it is being directly lit by the sun at that time. So that would be kind of a really cool thing to see if it weren't like pouring rain. So yay for rain, boo for missing out on kind of a cool view. If it's clear the next morning, though, you can still do this thing where you basically try to find like the oldest moon and the youngest moon successively. So Saturday morning, the moon is going to be even closer to the sun, even older. Like this is like a really ancient moon as far as moons go. But if it's clear Saturday morning, see if you can catch the moon. That's going to be a huge challenge. I dare anyone to do that. Find the moon after it rises Saturday morning before the sun comes up. So there, it's, another day older, 28.7 days old there. So that's going to be just the tiniest sliver, less than 1% illuminated. So if you can catch that and then turn around and look to the east, look to the west, the other direction, and wait another day for the sun to set. I don't think we'll be able to catch it Saturday evening, but Sunday evening should be a good time. So this is set, 16th, to try to catch, Monday evening, to try to catch the moon. It'll be less than 2 days old at that time. So 1.9 days, still just a tiny sliver, but probably far enough away that you can see it just after sunset. So fun thing this week, as we have a new moon, try to see the oldest old moon and the newest young moon that you can. I double dog dare you. So that's kind of our sky for the coming week. And then the other, just regular cool planets and stuff. With that, we might see a little bit more of this later because I have kind of an awkward jump planned for tonight. I don't know how it's going to work, but we're going to try. So we might see some more stellarium later. We might not. It'll be a surprise for us all. But for now, I want to pop back over to open space. So love getting out in space with open space. It's so relaxing. So this is all real data that's been loaded into this program. It's open source software that you can use to fly around the universe in 3D. So it's one of my favorite things to do in all my spare time, or not so much spare time. So we're kind of looking back in time. The time right now is set for September 2016 because that's when it's about time OSIRIS Rex was launching from the Earth. So I'm actually going to turn on some orbits so we can, for reference, so we can see the orbit of the Earth there. You can see you might be able to see the moon kind of going around it. And I guess we'll just kind of launch it off and see what happens. Let's just find out what's going to happen here. Like I said, it's just going to be a surprise for everyone. So I'm going to fast forward time to a few days per second and play. Woof. Okay, so there's the launch. So actually, let's go ahead and focus on OSIRIS Rex. And I'll slow it down a smidge and I'll just kind of chit chat while it's doing its thing. So it launched late 2016. It took about 1.5 years to kind of go around the sun and then did a little bit of a flyby to get a gravitational assist to Earth. So the green line you see in there, that's OSIRIS Rex. That's our mission that we're following. The kind of blue line, that's Earth. And then this purple line, that's our target. That's asteroid Bennu. So you'll notice usually think of asteroids as being out between Mars and Jupiter in the asteroid belt. Well, that's where the bulk of the asteroids are, but there's a whole lot that are a bit closer, a bit further. There's this debris stuff all over the solar system. It's a big, messy messy, messy place. Yeah, it's mostly a vacuum, so in that sense, it's kind of clean, but there's stuff all over the place. If you want to learn more about space debris, listen to the live stream I did a couple weeks ago. I had a guest co-host Brian Levine, who talked all about cosmic debris, like for half an hour. That's just all this stuff flying around in space. So for tonight, I just wanted to I'm going to have to pause time because otherwise this will break because there's a huge data set called the potentially hazardous asteroids. So that sounds friendly, like something that's just going to come up and shake your hand and offer you an ice cream or not, right? So the potentially hazardous asteroids, which there are a lot of, those are ones that are, potentially hazardous to life on Earth. Like these have a non negligible chance of intersecting with the Earth, like intersecting as in big boom. All right. So some of these are bigger than others, but yeah, Bennu is it's out there, right? So you see that little purple line. If you can still see, there's a little purple line in here. It's basically one of these, and it's like 1 in a few thousand chance that it might actually hit the Earth sometime late next century. It'll do a couple kind of close passes, and wouldn't it be nice if we knew something about that before it gets here? So yeah, let's go poke at it and see if we can agitate it a little bit. Why don't we? So I'm going to go ahead and turn those off so I can turn time back on. So those are all real data points, right? So uh, actual space rocks that are out orbiting around the sun that we are tracking, we being, I don't know, NASA and some other wonderful folks that are trying to, prevent anything bad from happening to us. So why are we going to this asteroid in particular? Because there's a lot of them. There's got to be a few that are a little bit closer. Well, Bennu is special in that it has a lot of chondritic material. So the material from it is actually from the very, very early solar system. So we're hoping to learn more about, our origins and how the planets formed and all these other worlds that we have in our solar system. And we get material for free, so to speak, free-ish, because it, intersects with the Earth. We have these meteors go streaking through the sky, and some of them land, and you can pick them up, and then they're meteorites, and you can open them up and look at those. So a lot of those contain material. Some of it is primordial material, like what we're finding on Bennu, and some of it is not. So some of it's from bodies that formed and were massive enough to kind of separate out into layers. We call that differentiation. So like the Earth has like a crust mantle core. Some of the larger asteroids, like Ceres, the largest asteroid in the main belt, it's actually a dwarf planet. So it's a differentiated body. So if we got a meteorite from Ceres, it wouldn't have like this primordial material that never like melted out. It'd be separated into like a stony part or an iron part or maybe that crazy missing mantle stuff. But Bennu we think is this primordial stuff. So that's pretty exciting. So one thing I forgot to mention that it is a little bit off the plane of the Earth, so it's like kind of like at a little bit of a tilt relative to the plane of the solar system. So you can see most of the planets line up in this plane, but then Bennu is going to be just a little bit off of that. So I'm going to slow time down because I think I'm getting about to the fun part, and kind of zoom in here. See if I can see. I didn't write down all of the dates. So OSIRIS Rex, I should actually say what it stands for. I'm really excited about OSIRIS Rex, partly because it's a sample return mission to an asteroid. So there haven't been very many of those. It's not the first one, but it's one of very few. And OSIRIS Rex, it's, I believe, what we call a backronym, where it's like we came up with a cool name and then had to make it stand for something that sounded science-y. So it stands for, I had to write this down because I can't memorize this, Origins, that's the O, Spectral Interpretation Resource Identification, Security Regolith Explorer, something like that. Okay. So a whole bunch of words. So it has, it's going to explore a comet, asteroid. not a comet. It's an asteroid. Might be a quasi comet. I guess there's some question about like anyway. We're just gonna call it an asteroid. I'm gonna try to keep calling it an asteroid. So the regolith, that's like the bumpy, rocky stuff. Like the moon has a lot of regolith, all the kind of loose, rocky material on top of like some stony material. And you know, it's going out there exploring. Oh, there it is, cute little thing. So it has these solar panels. Just kind of fly around here. It has these cute little solar panels. So it has, you know, its own power, sun powered, like you do. And the little kind of collection capsule, as best I can tell, this little bit up here, which, spoiler alert, the sample collection so far has been a success. All right. So in case you were wondering, on the edge of your seat, fret not. But let's see if we can't go through just a little bit more time here. I'm worried I may have missed the fun part. So when OSIRIS Rex actually got to Bennu, it did a couple of surveys. Oh, it looks like it's doing something there. So it did. Weird. Did I lose the asteroid? There we go. Let's go check out our asteroid. So it did a couple of surveys, kind of going around the polar orbit. Did like a polar orbit around around Bennu to kind of check it out, map it out a bit, and measure a bunch of things. Let's see if we can zoom in here and find. Woo! Oh goodness, it's spinning really fast. I forgot how fast it's spinning. So there's Bennu. This is kind of like our blocky view of Bennu that shows the shape. And it's spinning pretty quickly, so I need to step time down quite a bit. All right, so there we go, spinning. So a couple things. So the green lines, so those are from mapping that Bennu did. It's actually mapped out the whole thing. We have a really fabulous map that I'm going to try to switch over to in a little bit. It mapped out the shape. So it has this kind of like ellipsoidal shape. So kind of pudgy at the middle, then like, I don't know, like a cubey kind of shape. So it mapped all that out and all its bumps and whatnot. Turns out there's a lot more large boulders on the surface than we'd kind of bargained for. So OSIRIS Rex had to do like some serious mapping to try to find the best spots to go in and grab a sample. Also, because this thing is spinning so quickly, well, one other fun thing you notice about the spinning, you notice the direction that it's spinning. So if we look kind of in towards the sun, right, there's our... feel like I've flipped turned upside down. There's no up in space, but we do have kind of directional spins. So there we go. So it's actually retrograde, which is kind of neat. So it's this tiny little body floating around. It's less than a kilometer or less than half a kilometer across, so quite small. And it's spinning retrograde. So it's spinning the opposite direction that it's rotating around the sun. So here we would be like looking down on Earth's North Pole. Earth would be spinning around this way. But Bennu is, you know, little rebel of rubble that it is. It's spinning around all retrograde like. So that's kind of neat. And it's spinning up too, which is kind of odd. It's some phenomena that has to do with thermal radiation and its lighting effects. So it's actually increasing the rate at which it's spinning. So I don't know if it's just supposed to spin itself all the way apart at some point, but that'll be something to see. It actually like spurted out a bunch of material a little while back, and OSIRIS Rex was able to capture that event. Pretty exciting. Yeah, so the spin direction is exactly, it's determined using the right hand rule. So if you take your right hand, it only works if you use your right hand. That's why it's called the right hand rule. There's a separate rule for a left hand. But if you take your right hand and curl your fingers in the direction that the thing is spinning, your thumb points in the direction of its north pole, right? So in this case, its north pole is pointed the opposite direction that the north pole for other planets and other worlds in our solar system is going. So if you point your fingers in the direction that it's rotating around the sun, then your thumb is pointing one way. If you point your fingers and curl your fingers in the direction that it's rotating, then your thumb points the other way. That's what makes this little bugger retrograde. Very fun. So OSIRIS Rex did a couple passes, lots of mapping, and actually what I want to try to bring up so we can see just a little bit more of this material, we're going to go to Don't Actually Panic, but I'm kind of excited to use my panic button. So, so we're just going to kind of switch gears briefly. Don't panic. We'll be right back. We can actually, take a look at Stellarium and that nice open sky while I just switch over. So we saw kind of the shape that OSIRIS Rex mapped out, and because I'm not a computer genius, I haven't been able to get the shape to sync up with the map because it's a funky shape. It's not just a simple like sphere. So if I did this right, we should be able to. We'll go back to the panic because I'm really proud of that. We should be able to see the actual sphere of it with a little bit of a map. So I'm kind of faking it. Yeah. All right. So here we are back in the open space. Okay, so this is not the true shape of Bennu, right? So the true shape of Bennu with all its neat little bumps and ridges and the kind of the nifty equatorial ridge, that was what we saw before. But this is a real map. So originally they thought that there were very few large boulders, but it turns out that actually there are quite a few boulders on Bennu. We were hoping for not too many because that would make it easier to, kind of reach in there and grab a sample safely without potentially harming the craft or without, scratching the surface. This nice, pristine, primordial, whatever asteroid, you don't want to scratch it up, I want to break it. It's only been out there for like 5 billion years. Go there and break it. So because it's spinning so quickly, because there are so many boulders, OSIRIS Rex had to do multiple takes of, practicing coming in close and then backing off, practicing coming in and matching the rotation and then backing off. And also, while it was doing that, the scientists on the ground, and partly at the University of Arizona, Tucson, bear down, my alma mater. They were picking out which of several locations to go ahead and grab something from, and I think they decided on the one that was called Nightingale. Very beautiful. Is it hollow? Probably not. It does have a very low density. So if you've been tuning into some of the Moontopias, the next one of which is this coming Monday, a lot of the small moons, the smallest worlds in our solar system, are very, very low density, even less dense than water, because they're basically just big collections of rubble. And when OSIRIS Rex was measuring the gravitational pull and basically effectively the mass, and then therefore we could find the density, we found that its density is just a little bit more than water. So there are some moons and other small bodies that are less dense than water, which just tells us that they're very, very porous and they have a lot of icy materials. Bennu's pretty rocky. I'm not sure how much water ice is supposed to be in there. Probably some, but basically it has a high porosity, so it's very porous. Not all super tightly crammed together, and I guess it's just kind of odd that it has like much larger boulders on the surface than they thought. So over 200 boulders that are, what they say, 10 meters or more. The largest one is like 58 meters, so that's huge. I was going to try and find some. I really wanted to be able to find Ben Ben because I thought that was just a cute name. So one of the not so big ones, but I don't know if it's this one because it sticks up really high. So I don't have the elevation map in here, but Ben Ben actually sticks up really high. Just has a cute name. So I just wanted to shout out to that one. Um, so we've already learned quite a lot about Bennu without even getting our sample back to Earth. We've learned, about its porosity. We've learned about its density. We've seen that it has like all these boulders on there, which there was someone else, I don't remember where they were from, was doing a study about looking at these boulders and trying to analyze like how much it's been hit and kind of analyze, I guess, its kind of surroundings in the solar system based on the size of the boulders that are remaining. Because if you have, enough things that are large enough that smash into it, then that's going to break up any larger boulders into smaller boulders. So they were kind of doing an analysis of the impacts on Bennu based on the remaining boulders that haven't been smashed up to smaller and smaller pieces. The other kind of fun thing, when they did do the sample, they called it touch and go, tag for short, like tag, got you, you're it, but we're it. So the little touch and go was so successful. They got so much material that apparently the trap like didn't close completely and it was like leaking out some material. So they kind of moved up the stowing part of the procedure by a little bit, so they could get that stowed without having it all, leaking out into space, all our precious primordial solar system material. But that, I think a last check, that was just this week. It was a couple of days that it took them to go through all the procedures and make sure everything is buttoned up real tight and secure. So we have our sample and it should be coming back to Earth. I want to say 2023. It's going to crash into the desert in Utah and we'll get to go retrieve it and study it for a long, long time to come. So that's a little bit of OSIRIS Rex and Bennu. So I'm just going to go ahead and we'll flip through some time here. This is kind of going a little slowly. Yeah, we'll just zoom out and we'll call it a mission. A couple just quick announcements. Put up some credits. So again, if you liked this, we're doing another mission of the month. Next month is probably going to be Apollo 8 because it's kind of an anniversary and Apollo 8 is kind of awesome. Next Thursday for our tour, we'll be doing some other like sparkly starry things. There's a couple sparkly starry things I really want to do, and I need to get out of the solar system. I've been in the solar system for a while, but before that, next Monday, as I think I mentioned, is the next Moontopia issue. It's I believe we're calling it Chapter 6 Moontopia. That's going to be on the AAA Facebook live stream. So tune into AAA Facebook live stream 7:30 Monday night. It's Moontopia, and I really need people to tune into it because it's Chapter 6, Choose Your Own Adventure. So I'm going to need input from other people to help adventure around the solar system. So I'm a little bit nervous, but mostly looking forward to doing that, or at least attempting it. So thanks so much for joining me. Again, I'm Irene Pease, your Friendly Neighborhood Astronomer. You can find more random Friendly Neighborhood Astronomer stuff at friendlyneighborhoodastronomer.com. You can find Stellarium, download that at stellarium.org. You can find Open Space, download that for free at openspaceproject.com. Thank you so much for joining me for this little stroll around your celestial neighborhood. I just want to say, clear skies, be safe out there, wear a mask.